In this class, we start looking at various types of C++ statements that allow to control the flow of the program depending on the inputs that are being generated. So the first type of statement that allow to change the flow of the program is the if-else statement. Essentially, this allows to test if a certain condition is true or false. In the C++ language, we call this a Boolean, a condition that can have a true or false value. And based on the result of this condition, the execution of the program may take a certain path or a different one. So here is kind of the simplest form. So this is kind of a almost a pseudocode, in the sense that we just put a comment and not a particular real instruction. And so here we do if statement, check if the Boolean variable snowy is true or false, and if it's true, you go inside of the the braces, and so execute whatever program is inside here. Here we say go skiing. Otherwise, the flow continues after without executing the inside of this condition. Slightly more interesting is to have two alternative branches. So here we can say if is knowing. So if the condition knowing is true, we say, oh, I go outside, otherwise else I stay in. So this is a way to have two parts of the code executed depending on a particular condition. And then, of course, the flow merge back and continue after this condition. One can also take and nest this type of condition to get something a little more interesting. So here, for example, I say, oh, if it's winter, go skiing, first condition. And then we can go directly and say else if, and we check a second condition and say, oh, if it's true that it's summer, this is tested only if the first condition fails, right? So if it's winter, we just go skiing and then we jump all the way to the end. Otherwise, test if it's summer. Summer, true, you go hiking. But then if this second fails again, then we have a third option and you go and drink coffee. So let's take a look at how this kind of works a little bit in practice. We open a very simple program, and we'll see in another example something that is more interesting. But let's go back to our initial program where we look at the various type of classes. We enter the name of a student, and so read the name, and then we can look at the class that the student is registered in, and depending on the value of the class, we can greet the student as being part of a particular class, or once we exhaust the options, in this case the three options for this class, we can say, oh, sorry, you might belong to a different class. And we do this twice. So if the number of the class is greater or equal than 6,000, it means that we select among the graduate classes, or say you belong to a different graduate class. Or if the number is below 6,000, I mean, this is the convention here at University of Utah, then we say, ask the student what is the class, and maybe it's part of a different class. So we can execute this program, and we get asked, so the name is Valerio, my class is 5900, and then the response is welcome to bioengineering 5900, and then we have the completion of the class. If I execute again, I just type in my name again, Valerio, the class number. Let's say I put 5007. So no classes you recognize, and then the result is that, I'm sorry, you probably belong to a different undergraduate class. So here we see the flow of the information. If the class is below 6000, then we start comparing the code with computer science, ME, bioengineering, and if none of those is satisfied, then we say, oh, you belong to a different undergraduate class. So this is kind of the way the execution of this type of instruction happens within a particular piece of code. There are additional interesting way of making the flow of the code proceed, and also different way of testing if a formula is true or false. As we saw, one can put just a variable and see if it's true or false, but more intuitively, kind of the way we do it in this program, we test if a particular condition is true, right? So here, let me clear here. So here, let's say if class code for bioengineering, it's equal to my class, and notice that is the double equal sign, so it's not an assignment, but is a Boolean test, it's a condition. So here we see the different type of comparison. So either we evaluate a particular Boolean expression, or we test if two values are equal, two values are distinct or different, is one greater than another or smaller, greater or equal. So those are the typical kind of intuitive mathematical comparison. Also, one can check if two conditions are equal at the same time, and which is the double ampersand. So here, for example, would be if A greater than B and B smaller than A, and then the condition is satisfied. So we'll see throughout the semester all kind of combination of using those, and so we should just take it as logical condition that we use over time. Go over quickly in some other examples. We'll take those more in detail in the future. If we want to start looping over certain conditions, so keep repeating a certain statement over and over until a certain condition is true. Here, for example, we have this what's called the while statement. So where we evaluate if a certain condition here, it's awake equal true, and while I'm awake, I print getting coffee. Now this program alone basically would run forever because the condition is true and never changes, right? So if we want to run this a certain number of times, at some point we will have to change awake from true to false, so that the loop, the repeated computation inside this loop stop. Other way to have loops, so you have, this is the general structure, you have a test and the body of the test. So the way to have a loop that stops, so here, for example, say I want to take a certain number of cups of coffee instead of just repeating that. And so here, if I initialize number of cups to 0, I test. If the number of cup is smaller than 10, I print a statement getting coffee, and then I increment the number of cups by 1. So the first execution, this will, number of cups is 0, then 1, then 2, until it reaches 10. At that point, this statement, the Boolean, is false, and the inside is skipped altogether, and the execution of a program will continue. There is a specific way of doing loops for counting things, and this is called the for loop. So the loop equivalent to what we see above would say, would be structured this way: for number of cup is equal 0, as long as number of cups is smaller than 10, And then we have this special instruction that says number of caps is incremented by 1. So this instruction is the equivalent of this one. In fact, one can use one on the other. And then say, oh, getting coffee. So those two loops are completely equivalent. And so the reason why we use for is that because this is such a common pattern that for the language it's better to have it represented explicitly, and also make it easy, for example, for the compiler to do some optimizations. So this would be the general structure of the for loop. So in the first part, it's kind of the statement initialize the value. That's what in the while was before. It's a test to where if as long as it's true, the loop continue to be executed. And then what we do after to update the value of the looping variable. So here again, initialization, number of caps equals 0, test, number of caps smaller than 10, and then incrementing the number of caps. And so this loop get executed 10 times. So this is all for today. Again, this is something we'll go over many times. Those are very important instructions. And we will have a couple of more videos taking another example code and show how to use the alternative execution in different way. Thank you.